Alright, so this is my third time recording this video now because the last two times my computer shut down. So let's hope nothing goes wrong this time. So this video is about another way that we can represent functions. So today we're going to be talking about how we can use equations to represent a function. So remembering that a function is a relation in which each input has only one output. So a relation means two sets of numbers that are related to each other. And then when we say each input can only have one output, we mean if the input is 2 and you get out 0, you couldn't then have an input of 2 again and get out 5, right? Each input can only have one output that goes with it. So we've looked at functions represented as tables, like we have here. We know we can write them out as coordinate points, and then after we write them out as coordinate points, we can put them on a graph. So we've been looking at this stuff for a few weeks now, but I want to do a quick review and then use this example to explain how we can use an equation to represent the same thing. So I'm going to look at the first row in the table, and my x value is 2 and my y value is 0. So I'm going to write that as a coordinate point, where we put the x value first and then the y value. It's represented pretty much the same way as the table, but the coordinate point tells us where to put it on the graph. So my x value is 2, so I want to find my x-axis. I see x right here. So my x-axis is going to be the one that goes horizontal, or side to side. My x value is 2, that means I'm going to go over 2. And then my y value is 0, so I'm not going to go up or down at all. So my first point is going to be right there. Alright, the next row in the table has an x value of 3 and a y value of 1. So my coordinate point is going to be 3, 1. So this time I'm going to go over 3, since that's my x value, and I'm going to go up 1, because that's my y value. Now you might be saying, wait, you didn't go up 1, you went up 2, because if we count the boxes, there's 2 little boxes. But you always want to look at how the graph is labeled. So in this case, 2 boxes represents just one number, and I know that because I can see the numbers over here on the side. 1, 2, 3, so on. So my second point was over 3, up 1. The next point is going to be over 4, up 2, and then over 5, up 3. Okay, great. So now I have 3 different representations. I have the table, I have the points, and I have the graph. And all 3 of these things right here, these are all representing the same function. It's just being represented in different ways. So now, let me move this out of the way here. There we go. So we're going to use the equation to say exactly how the input is related to the output. So I know it's an equation, it's going to have an equal sign. So I started out by just putting my equal sign here in the middle. Now the 2 things that I'm relating to one another are the input and the output. And we know that we can use x to represent input and y to represent output. So I'm going to start by just putting my x on one side of the equation and my y on the other side of the equation. And I left all that extra room because we're going to have to put some numbers into this equation as well. And we'll have to do that because if we left the equation just like this, x equals y, that would mean that our x value would always be equal to our y value. And that's not true. 2 is not equal to 0. 3 is not equal to 1. 4 is not equal to 2, right? So to say that x equals y is not true. So you want to look for a pattern. So in this example here, I'm just going to tell you what it is. Later on in the semester, we'll work on figuring out the patterns ourselves. But here, every time that you have an x value, you're subtracting 2 to get your y value. So our equation that represents this function would be x minus 2 equals y. Or you can flip that around and write it in reverse. And that would be y equals x minus 2. Now, the only reason that we would flip it around like that and write it in the opposite order is because the y is by itself. So it makes more sense to have it first. So now we have this equation here. And this equation is representing the exact same thing as this graph is, which is representing the exact same thing as the numbers in this table. Okay, so in that example, we kind of worked backwards. We had the table first, and then we made the equation. In these examples, the equation is given to you first, and we're going to use that to fill out the table. So my first equation is y equals x minus 2. So this is very similar. Oh wait, this is the same as the one from before, but we can use it for any number. So in our table here, the numbers we had were 2, 3, 4, 5, but we could pick any number and use that equation for it. So let's say we had an x value of 10. We would do the exact same thing. 10 minus 2, that's going to give me 8. So my y value is going to be 8. Then 0 minus 2. So 0 minus 2, that's going to take me into the negatives. It's going to be negative 2. On our graph here, we only had positive numbers, but we could extend our graph more to have negative numbers as well if we wanted to graph that. All right, next part, negative 5 minus 2. We start at negative 5. We go further back into the negatives. It's going to be negative 7. And then 100 minus 2 is going to be 98. So no matter what the numbers are that are given to you in the table, you always just apply the rule to it. And the equation is what tells you the rule. So in the next table, I gave us 3 columns. And the middle one is just to show your work. Sometimes it's easier to set it up this way so that you can follow step by step, but it's also okay to just do your work off to the side if you would prefer that. So this time our equation is y equals negative 5 times x. So remembering that when we have the number and the variable right next to each other like that, that means multiplication. So each time I'm going to take negative 5 and multiply it by whatever the x value in that row is. So our first x value is 10. So I'm taking negative 5 and multiplying it by 10. That will give me negative 50. Then we have negative 5 times 0, which is just 0. Negative 5 times negative 5. Negative times a negative is a positive. That's positive 25. And our very last one is going to be negative 5 times 100. That's going to give us negative 500. Okay, now, so we've done an example with subtraction, we've done an example with multiplication. Sometimes an equation will have more than one rule that's applied to it. So here we have y equals 2x minus 5. So this time, x is being multiplied by 2, and then you're subtracting 5 to get your y value. Now here in the middle column, we're going to use this to plug in that number. So we have 2 times whatever our x value, this time it's 1, and then subtract 5. Now I'm going to go ahead and fill in the middle column all the way down, and then we can actually crunch the numbers. So in the next row, we would have 2 times 3, and then subtract 5. 2 times 5, subtract 5, and 2 times 10, subtract 5. All right, now I'm just going to crunch these numbers. We know that multiplication would come first here because of our order of operations. 2 times 1 is 2, minus 5 is going to be a negative number. It's going to be negative 3. Okay, in the next row, we have 2 times 3, which is 6. 6 minus 5 is 1. So you have to remember to do both steps. I think the biggest mistake that people make is they'll just do one step and not the other one. So they'll either multiply it by 2 or subtract 5, but not do both. So you want to make sure you're doing both steps. 2 times 5 gives us 10, minus 5 is 5, and 2 times 10 is 20. 20 minus 5 is 15. Okay, now I gave you 2 more practices at the bottom that I want you to go through and try on your own, and I'll be posting those answers tomorrow. And then you will also be doing an IXL just to make sure you really have this down. So reach out to me via email if you have any questions or on our next Google Meet. I hope this helps, and good luck.